Hello everyone, how are you? I hope that you are all safe. Again, this is me, Mom Rhoda, and I am your teacher in Science 8. Now, let's discuss about what? We will be discussing about a new lesson which is about the law of acceleration or Newton's second law of motion. Are you all excited? I hope that you are all excited. The objectives for our new lesson today is for you, the students, to first define what is acceleration. Second, identify the relationship between force, mass, and acceleration. Lastly, is for you to state Newton's second law. So before we go to our topic, let's first have a short review about the units of measurement. Please watch this video.
Measurement. We use the words like taller and shorter to compare the height, and words like heavier and lighter to compare the weight of different things, animals, or people on a daily basis. There are different units in which we measure the height, weight, time, distance, etc. Let us study these different units of measurement today. Measuring weight. We measure the weight of solids in grams and kilograms. 1000 grams is equal to 1 kilogram. Fruits, vegetables, and grocery items are also measured in grams and kilograms. These are the normal weights that a greengrocer and grocer have. We use a weighing balance to measure the weight of objects. Some people use a spring balance. Thousand milliliters is equal to 1 liter. As liquids take the shape of the container, it is the capacity of the container which determines how much liquid it can hold. Measuring jars come in different capacities. Next is measuring length, height, and width. In early times, people used parts of the body for measuring length. There were two main objections to these early units. First, if the units were based on the size of a body part, it would be different when measured by different people. Secondly, the various units like handspan, cubit, fathom, etc. would have no connection with each other. Later, units like feet and inches were used to measure the height, length, and width of all objects. Now, all over the world, the metric system is being accepted for measuring these three dimensions. "100 centimeters is equal to 1 meter. 1000 meters is equal to 1 kilometer. Long distances are measured in kilometers. These are instruments used for measuring length, width, and height. Measuring time. We measure time with the help of a clock or a watch. The standard unit of measuring time is seconds. 60 seconds make 1 minute. 60 minutes make an hour. Temperature tells us how hot or cold an object is. It is measured by a thermometer. It is expressed in degrees, that is Celsius or Fahrenheit. Whether it is cooking or it is building houses and bridges, whether it is making soaps and toothpaste, or it is buying and selling things in the market, measurement is extremely important.
Now that you have finished watching, I want you to answer these questions. Column A should be connected to column B. Okay? Try to answer this. Now it's time to check your answers. Now what will be the unit for time? We will be using, of course, seconds, minutes, and hours. For water or other liquids, we are using L for liter or ml. Hey, it's not Mobile Legends, okay? ml means milliliter. Okay? Next, we have the force. We are using Newton. Next, we have mass. We are using G for grams or kg. Next, for acceleration, we are using meter per second squared or ms2. Now let's ignore ignore the other units first, okay? Let's focus on force, mass, and acceleration, okay? Newton's second law of motion. Mom Rhoda, what does that mean? Wait, we will be learning deeper, okay? Relax first, relax. Again, Newton has developed three laws of motion. First is the law of inertia. But now, our lesson for today is about the second, which is the law of acceleration. What is acceleration? It means it's a measurement of how quickly an object is changing speed. Question: which ball is lighter? Next, which ball is heavier? Answer: the bowling ball or the baseball. We already know that the baseball is lighter and the bowling ball is heavier. Now, for the third question, which ball is easier to throw? And which ball is easier to throw, the bowling ball or the baseball? Next, which ball is harder to throw, the bowling ball or the baseball? It's easier to throw the baseball than the bowling ball. And the bowling ball is harder to throw than the baseball. Why? Because it's heavy. Now, the question is, if you will throw using the left hand or the right hand, and you use the same amount of force to throw the ball, the bowling ball and the baseball, which would accelerate or move more? Will it be the baseball or the bowling ball? Which will accelerate more? The answer is it will be easier to accelerate the baseball. Why? Because it is lighter compared to using the bowling ball. Okay? Now next question is, what is the relationship between force, mass and acceleration? If an object has more mass, then it means it will less likely to accelerate if we use the same force. Like, look at this picture. The example, there are two balls. One is a big ball and the other one is a small ball. If you use the same force, the smaller ball, which has a lighter mass, of course, will be easier to accelerate compared to the big ball, which is heavy. Now look at this picture. The man is pushing two carts, okay? Look at the mass. They have equal mass. The mass stays the same for both pictures. But look at the force. If you will push this using a smaller force, the acceleration would also be slow, like. But if you would be using more force, the acceleration would be greater. Then look at this picture. Look at the mass of the two carts. In the upper picture, you would see there's only one box. So if you will be pushing this one box using more force, it will accelerate more compared to using just a normal force on a heavier object. Newton put this relationship between force, mass, and acceleration into a mathematical formula, which is now known as the law of acceleration. We will be using this formula when we will be solving problems about it, okay? So it's A for acceleration. A means acceleration is equals to force divided by the mass. So A equals to F over M. Then what does it mean? Acceleration and force, the relationship between acceleration and force is directly proportional. Again, it's directly proportional. So that means that if force increases, then acceleration would also increase. So that means like this. You look at this mouse. If I will be using a great force on this mouse, then it will move like that. It would accelerate. But if I will be using a smaller force on this mouse, then it will accelerate less. Okay? Then what is the relationship between acceleration and mass? They are not directly proportional, but inversely proportional. So that means if mass increases, then that means acceleration would decrease. And if there is a little mass or a lighter mass, then acceleration would increase. Okay? So for you to understand more about this, please watch this video. Now that you know about the law of acceleration, now what would you like to do? You would be answering your modules, and again, stay home, stay safe. God bless you all.